Hi students, one more video based on linear programming problem whenever we are going to use the artificial variables, that is two-phase method. And what is meant by two-phase method means you will be having two phases, phase 1 and phase 2, whereas in the phase 1 we are going to take the coefficients for the slack variables and decision variables and surplus variables all as zeros, except for the artificial variables you are going to take -1. Whereas in the phase 2 we are going to take the actual coefficients of the given question. When the phase 1 will be completed is the value of z will become 0 and all the zj minus cj values has to be positive. That means all zj minus cj must be greater than or equal to 0. Still then the phase 1 will be completed. Then under phase 2 we are going to write the values from the previous table, that is initial or any other simplex table, initial or first or second, where you got the phase 1 completed. By dropping of the artificial variable values, we are going to write the two-phase method second phase by giving the table name as modified simplex table. Now we are going to move on to the problem. So here they have given the question based on the minimum objective function. When it is of minimum, you have to convert it into maximum by giving a z star value by multiplying the objective function with -1. That is what we have done here. Minimum to maximum problem, where maximum z star is equal to minus minimum z, which is nothing but given objective function is having here 15/2 into x1 minus 3x2. Here it will be minus 15/2 into x1 plus 3x2. Now we are going to write the standard LPP form. The standard LPP form, here it is maximum z star is equal to minus 15/2 into x1 plus 3x2. And what are the constraints here? They have given two constraints which you have both are greater than or equal to only. That means you are going to get one surplus variable, that is here minus s1, and for the second constraint minus s2 plus a1 plus a2. So here this will be your constraints. We are going to make it as an equality constraints. So whatever the decision variables and surplus variables and artificial variables, you are going to suppose to take that or positive. Now in the initial basic feasible solution, we will be having all the decision variables. Here they have given three decision variables, x1, x2 and x3. All are 0. Then you are going to get the artificial variable values as a1 equal to 3 and a2 equal to 2. While substituting these three values in the maximum z star, you are going to get that in the place of a1 3 and in the place of a2 2, that is -5. Now you got the maximum z star as -5 in the initial simplex table, whereas we are going to write the phase 1. See here I have written take coefficients as 0 for all the decision variables, surplus or slack variables, except for the artificial variables. So whatever the decision variables and whatever the slack variables and whatever the surplus variables are there, but in this problem we are having the surplus variables. That's why we are going to give that the coefficient as zeros and give the coefficients for artificial variables as -1. Okay. So here it is the initial simplex table. The proforma is same. CB, basic variables, XB, X1, X2, X3, S1, S2 and A1 and A2. I already told you the basic variables are nothing but a1 and a2. The coefficients which we have been taken as -1 for both, and cj values except for the artificial variables in phase 1 you have to give zeros. So x1, x2, x3, s1, s2, here s1 and s2 are the surplus variables and a1 and a2 are the artificial variables. For artificial variables we have been given -1 as the coefficients, and we have been taken these values as the coefficients from the constraints, and this is the values. We are going to have the value of z star. The formula is z star is equal to summation cbxb, where summation cbxb means 3 into -1 minus 3 plus 2 into -1 minus 2, that is of -5. zj, in the same way you are going to find out the zj, 3 into -1 plus 1 into -1 minus 4. Similarly you are going to find out all the zj values. Now we are going to find out the zj minus cj values. What is the formula for zj minus cj? -4 minus 0, you are going to get -4. 2 minus 0 plus 2. 0 minus 0, 0. 1 minus 0, 1. 1 minus 0, 1. 0 minus of -1, you are going to get +1. Here it is of 0. Now, what is the most negative value? This is the most negative value, which is nothing but -4. So this is your incoming variable. Then after finding out incoming variable, what is the outgoing variable here? Here the formula is minimum ratio is equals to xb by x1. xb by incoming variable, that means 3 by 3. Here it is 1. 2 by 1, that is 2. Out of these two, what is the minimum value? 1. So this is your outgoing variable. In bigger method, if artificial variables are outgoing variables, that is in the previous method, via previous problem which I have been already explained, if artificial variables are outgoing variables, you have to drop off that variable from the simplex table that is there in the bigger method procedure, but not here. So instead of writing the values of a1, the values of x1 you are going to write in the first simplex table. So a1 is the outgoing variable. In the place of a1 you are going to write the value of x1. So what is the variable for x1 coefficient? 0. And a2 is as it is, you are going to write -1. Here it is, a2 is -1. Okay, now we are going to do the row operations, where what is meant by key element? The intersection of the incoming variable and outgoing variable is called key element. Here the star represents the key element. So this you have to make it as 1. To make it the key element as 1, we are going to divide the first row, that is R1, divided by 3. That means the whole row you are going to divide it by 3. After doing that, you are going to get this row. See, I have written that the R1 dash, that is the new row in the first simplex table. R1 dash is replaced by R1 by 3. So R1 by 3. So here you are going to get 3 by 3, 1. 3 by 3, 1. Minus 1 by 3. Minus 1 by 3. Minus 1 by 3. 0. 1 by 3 and 0. And here in A2, 1. See, how you are going to write this? Here it is 1. Instead of getting here 0, just we are subtracting the new row from the old row. That is nothing but R2 minus R1 dash. After doing that, you are going to get. For that, I have been done the values for you. So R1 dash values you have written here, and R2 is nothing but here. So after subtracting, you are going to get 2 minus 1 1, 1 minus 1 0. This is the new row what you are going to get. This is the new row you are going to write in the place of R2 dash. Again you have to find out z star. Z star is equals to minus 1. Now finding out the value of zj. See here, this is the values of zj, that is nothing but you are going to get 1 into 0 plus 0 into minus 1, 0. Similarly here it is. All these values you are going to find out like that. Now zj minus cj is nothing but 0 minus 0, 0. 2 by 3 minus 0 plus 2 by 3. 4 by 3, sorry, minus 4 by 3 minus 0 minus 4 by 3. Likewise you are going to find out zj minus cj. See, here you are not getting any optimum value. When the phase 1 will be completed, the value of z should be as 0 and all the zj minus cj values must be positive. Then only you have to end the phase 1. So here most negative value. What is the most negative value in this? Minus 4 by 3 or minus 1 by 3? Minus 4 by 3. Okay, so this is the most negative value. That's why you are going to write the incoming variable. What is the outgoing variable? You are going to find out the outgoing variable by taking the minimum ratio formula, that is xb by x3. 1 by negative value. Negative values you are not going to write in the minimum ratio column. That's why keep it as 0. That is dash. And here it is 1 by 4 by 3. You will be getting 3 by 4. So this is the least value of the minimum ratio. So this is your outgoing variable. That means A2 is the outgoing variable, X3 is the entering variable or incoming variable. In the next table, that is in the second simplex table, you are going to write that. So here minimum ratio, sorry, here the basic variables are x1 and previously x1 and a2. A2 is the outgoing variable, no? That's why x3 is the entering variable. You are going to write the value of x3. What is the coefficients for those two? Zeros. x1 is 0 and x3 coefficient is 0. Now these two values which we are going to get by using the row operations. What are the row operations here you are going to use, ma? While here the new row is nothing but this is the key element, star is the key element. In the place of key element we have 4 by 3. If you are multiplying with 3 by 4, you are going to make the key element as 1. That's why R2 double dash is replaced by R2 dash into 3 by 4 you have to do. That is the new row operation. See, R2 dash is replaced by R2 double dash is replaced by R2 dash into 3 by 4. After multiplying that, you are going to get this new row. 3 by 4, 0, minus 1 by 2, 1, 1 by 4, minus 3 by 4, minus 1 by 4 and 3 by 4. Now, here in the place to make it as 0, you have minus 1 by 3. See, I already told you key element should be 1 and the values which are there in the key column should be making it as 0. So minus 1 by 3 you have to make it as 0. Here it is minus 1 by 3. Here in the new row you have 1. Then you are going to add these two values by multiplying the second row value with 1 by 3. So I have written that new row operation, which is nothing but R1 double dash is replaced by R1 dash plus 1 by 3 into R2 double dash. For that I have been done the row operation here. So R1 dash, R2 double dash and plus 1 by 3 into R2 double dash. See, R1 dash I have written here. Here this is of R2 double dash. R2 double dash is nothing but new row in the second simplex table, that is the second one. which you are going to multiply with 1 by 3. See, 1 by 3 into R2 double dash. These are the values you will be getting. The value of R1 double dash, whatever you got here, by adding the first one and third one, which I have ticked. By adding these two, you are going to get this line. This whole line you are going to represent in the place of R1 double dash. So now you have to check that the value of Z star and Zj minus Cj. See, the Z star is nothing but, as the coefficients are zeros, you are going to get the Z star value as 0 only. Now finding out the value of Zj, as the coefficients are zeros, all the Zj values are zeros only. And Zj minus Cj, all these values are 0, and 0 minus of minus 1 plus 1. 0 minus of minus 1 plus 1. So here the Z star have become 0 and the optimality condition has been satisfied. So we are going to end the phase 1 here. Now we are moving on to the phase 2. For that sake, we are going to write that in phase 2, while we have been named it as modified simplex table, we have to write the previous phase 1 end table values by taking the actual coefficients from the given objective function and leaving the artificial variables. So what is the last one? See, without writing these two artificial variables, we are going to write the same values by taking the name as modified simplex table, and for the values of x1 and x2 and x3, whatever they have been given in the question objective function, that coefficients you are going to write here. I have written here. So this is your value. In the question they didn't give about the value of x3, that's why I have put it as 0. S1 and S2 are zeros usually. So minus 15 by 2 and 0. x1, x3. See here in the previous simplex table you have x1 and x3. That's why I have written x1 and x3 here. Minus 15 by 2 is the coefficient for x1. That's why I have written here. And x3 coefficient is 0. That's why I have written x3 coefficient as 0. Now you have to find out the value of Z star. What is the value for Z star? See, summation CB XB 5 by 4 into minus 15 by 2 plus 3 by 4 into 0. So whatever the values are there here, there is no need to multiply with the coefficient. Why? Because it is 0 only. So 5 by 4 into minus 15 by 2 minus 75 by 8. Here it is 1 into minus 15 by 2 minus 15 by 2. Like that you are going to find out the Zj values. Now you are going to find out Zj minus Cj. See, if it is of positive, we are going to end this phase 2 also. If all the Zj minus Cj are not positive, again you have to proceed with the actual simplex table method. Okay. So the solution is optimum here. All the Zj minus Cj is greater than or equal to 0. So the phase 2 also completed. How much you got the value of Z star? Z star is equal to minus 75 by 8. And by substituting the value of x1 is 5 by 4 and x3 is 3 by 4, where the value of decision variable x2 is equal to 0 is not there in the last simplex table. See, so this is your modified simplex table now. So x1 value is 5 by 4, x3 value is 3 by 4, there is no value of x2. So x2 is 0 and Z star is 75 by 8. You are going to check this by keeping the values of x1 and x3 in the objective function. So here it is converting the Z star is equal to minus 75 by 8. Minimum Z is equal to, you are going to get that while multiplying it with minus 1, you are going to get the minimum Z, that is of 75 by 8. This is the checking point. Minimum Z they have given the question, that is 15 by 2 into x1 minus 3x2. Substitute the value of x1 and x2 in that. You are going to get the minimum z value is 75 by 8, which is equal to the value of minimum z. Hope you understood this video. Thank you.